Hello students, good afternoon everyone. So today we will start a new chapter, that is determinants. Before starting, let us go to synopsis, the points. Suppose you have a matrix A. It has A, B, C, D. Then determinant of A is written like this. Determinant of the matrix is written like this. And the answer will be, first you have to multiply this way, cross way AD minus, now you have to multiply cross way like this, BC. This is called determinant of 2 by 2 matrix. This is how you will find. For example, with numbers, suppose if the matrix is 1, 3, minus 7, 2, a 2 by 2 matrix, you have to find determinant of A. That is, you have to find determinant of 1, 3, minus 7, 2. So first you will multiply 1 and 2. 1 into 2 is 2, minus, now multiply minus 7 and 3, minus 21. So it is 2 plus 21, that is 23. This is how you will find determinant of a square matrix, 2 by 2. You can find determinant of only square matrices. Only square matrices you can find the determinant. So 2 by 2 matrix is very easy. But when you come to 3 by 3 matrix, like if you have A, B, C, D, E, F, G, H, I, a 3 by 3 matrix, then how to find the determinant? First, you have to take A and multiply with determinant of, remove the A row, remove the A column, the left of elements E, F, H, I. Next, minus. Next, you will take P. So this time you will have to take P into determinant of, you have to remove the P row and B column. The elements left are D, F, G, I. And then after that, next, plus this third number C into determinant of, you have to remove the C row and C column. Left elements are D, E, G, H. After that, A into multiply EI minus HF minus B into DI minus GF plus C into DH minus GE. This is how you will find the determinant of 3 by 3 matrix. It is not necessary that you have to take only first row. You can take first column also. Suppose if you want to find the determinant of A, B, C, D, E, F, G, H, I. If you want to find the determinant, then you can take A into, remove A row, A column, determinant of E, F, H, I. Then instead of row, you can go to T minus D instead of B. Seeing row wise, instead of seeing row wise, column wise, minus D into minus D into, remove the D row and D column. The left elements are B, C, H, I. And then next, plus last number G into, remove the G row and G column. Left elements are B, C, E, F. Like this you can do, and after that like this also, whatever I did, same that way. Not only first row, first column, you can go with second row, second column also. Like A, B, C, D, E, F, G, H, I. If you have, if you want to go to second row, D, but minus D into, minus D. Leave the row and column. The left of elements are B, C, H, I. Okay, then next is E. Plus E into, remove the E row and E column. The left elements are A, C, G, I. And again, minus F into, remove the F row and F column. The left elements are A, B, G, H. Like this also you can multiply. So basically, if you are given a matrix A, B, C, D, E, F, G, H, I, you can use any row, any column to find the determinant. But remember, the signs which you put, plus minus. If you take A, plus minus plus, minus plus minus, plus minus plus, these are the signs to be put. Whichever row you take, whichever column you take. Remember that. Remember the signs. Alternate. 1 plus minus plus, plus minus plus, minus plus minus, plus minus plus, like that. Alternate. If you are finding the determinant of A and you are getting some number, then what you can call? You can call it as non-singular matrix. A is non-singular matrix. But if determinant of A is 0, then you call A is singular matrix. Can you find the determinant of this matrix and tell me? I'm giving you one question. Find the determinant of this matrix. What happened? No one is giving the answer for such an easy problem. Are you listening or sleeping?
Listening, ma'am.
Okay.
Good afternoon, ma'am.
Good afternoon. Find determinant of A and tell me the answer. What happened? You have to multiply 1 and 6. 1 into 6 minus 2 into 3. It is 0. So this is a singular matrix. Okay, I'll give you next question. Find the determinant of this. Yes, Vinayaka told first. Correct. You have to multiply 1 into 4 minus 2 into 3, 6. Minus 2 is the answer. Minus 2, Vidya. Correct. Vidya is correct. Vinayaka, you said 2. It is minus 2. Not plus 2, it's minus 2. Okay, next. Minor. What is minor? Suppose if I give you a determinant A, B, C, D, E, F, G, H, I. I want to find minor of A. So I will remove the A row and A column. Absolute value of E, F, H, I is the minor. What it is? E, I minus H, L. This is minor for A. Similarly, if you want to find minor of B, how will you find minor of B? You will remove B row and B column. What is left? D, F, G, I. That is Di minus. Any element you can find. Suppose if I ask you, find minor of F. Where is F? This is F. So remove the F row and F column. What is left? Determinant of A, B, G, H. AH minus BG. Okay. So now I will give you a determinant. You have to find minor. Okay. Yes, I'm giving you matrix. Here is the matrix. You have to find minor of 1, minor of 2, minor of 3, minor of 0, 5, 0. 1, 2, 3, 0, 5, 0, 2, 4. Find the minors of all these. For instance, I will do 1. Minor of this 0. Suppose if I want to find the minor of this 0. Then what I will do? I'll remove the 0 row and 0 column. 1, 2, 2, 4. So I'll write here 1, 2, 2, 4. Cross multiply 4 minus 4, 0. All of you find the minor one by one. And tell me all the answers at a time. Total 9 minors you have to tell me. Separated by columns, commas. Separated by commas. Find all the 9 minors. Tell all the 9 answers at a time, putting commas. So many people gave answers. Who gave first answer? Vidya gave the first answer. But Vidya's answer are different from Lohit's answer. Lohit's answer is different from Maunika's answer. I will put it on the board. Check. Minor for 1 is 15. Minor for 2 is 0. Minor for 3 is -10. Minor for this 0 is -6. Minor for 5 is -3. Minor for 2 is -15. Minor of 4 is 0. The next, minor of 3, 5. Let us see who is correct. 15, 0, -10. So Vidya is correct. Lohit, you went wrong. Okay, next. -6, 3, -3, 0. -6, -3, 0. Vidya is correct. Then 50, -15, 0, 5. -15, 0, 5. So finally, Vidya's answer is correct of all. Next, similar to minor is cofactor. Suppose you have A, B, C, D, E, F, G, H, I, determinant, and you are finding cofactor of A, cofactor of B, cofactor of C, like that. So first what you have to do is you have to put the signs plus, minus, plus, minus, plus, minus, plus, minus, plus. Next, to find cofactor, first plus A, and as you did minor, same way. What is, how did you do for minor? E, F, H, I. So A into E, I minus H, I. That is A, E, I minus A, minus A, H, F. Okay, next. What is cofactor of B? It has minus sign. So minus B, and then same cofactor of B, DFGI. Minus B is outside, DI minus GF. That is minus BDI plus BGH. Like that, you can find cofactor of every element. But don't forget to put plus minus. After finding the cofactors, you can write the cofactor matrix. How? How will you write cofactor matrix? The answers which you get here. For example, answer for this is L, this is M, this is N. So you will put L, M, N in serial order, like A, B, C are in a row, L, M, N also will be in the row. Similarly, you will find cofactor of D, E, F. Suppose if we had OPQ, cofactor of GHI, say RST. This is called cofactor matrix. Next is adjoint of a matrix. What is adjoint of a matrix? Suppose you have a determinant A, B, C, D, E, F, G, H, I. You will find cofactors. How to find cofactors? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So what you will write? Find the cofactors. Find the cofactor of A, cofactor of B, C, D, E, F, G, H, I, all. Suppose you will get L, M, N, O, P, Q, R, S, T. Then you will make cofactor matrix. The first one, I took a determinant or a matrix. Then I am making cofactor matrix. It will be first row LMN, second row OPQ, third row RST. Third row is RST. Cofactors you will write. Now, if this cofactor matrix is A or B or C, then if you take the transpose of this cofactor matrix, LOR, MPS, NQT, transport of the cofactor matrix, that is only inverse of, sorry, adjoint of A. After cofactor matrix, what you have to do? Make the row as column. Take transpose. Make the row as column. Make the row as column. That is called adjoint of matrix A. Okay, now I will ask you to find adjoint. Try. Let us see how many will do. Find adjoint of matrix. Oh, good. No, Kumar. Adjoint will be not like this. Adjoint will be like matrix. You have to write not a number. Did you see how did I write? This is adjoint. First, you have to find cofactor. Okay, this one, shall I do it? Let me see if someone will do. Let someone do it and tell me the correct answer, then I will explain to you.
A equals 1, 2, 3. 1, 2, 3. Tamuna 0, 5, 0. Tamuna 2, 4, 3. 1, 2, 3, 0, 5, 0. 2, 4, 3.
Who is that speaking, Kumar? Lohit gave the first answer. Vidya also gave. But Lohit's answer is correct. Let me tell you what to do for those who did not do. First, write plus minus plus, minus plus minus, plus minus plus. Find the cofactor of 1, 2, 3, 0, 5, 0, 2, 4, 3. How you will find? For 1, you will write plus determinant of 5043. But for 2, you will write minus 0023. For 3, you will write plus 0524. For this 0, you will write minus 2343. For 5, you will write plus 1323. For this 0, minus 1224. For 2, plus 2350. For 4, minus 1300. And for 3, plus 1205. So the answer here will be 15. Here 0. Here minus 10. Here 6 minus 12 minus 6, which will become plus 6. 3 minus 6 minus 3. 4 minus 4, 0. Minus 15, 0, 5. Now, if you want to write the adjoint of the matrix, the first 3 you will write as column. You have taken 1, 2, 3 rows you have taken, but the cofactors you will write as column. The next 3, again second column. The last 3, third column. like this you will write. Is that clear? So this is adjoint matrix. This is adjoint matrix. So Lohit, what you have written is cofactor matrix. Yeah, Lohit, now you have written correct, second time. Second time you have written correct. Vidya, you also have written cofactor matrix. Take the transpose of cofactor matrix, you will get adjoint matrix. I hope this is clear to everyone. I did it. Okay. The next is there are some properties of adjoint matrix. Okay, here you have properties of adjoint matrix. Adjoint of A into A is equal to A into adjoint A equal to determinant of A. Adjoint of AB is equal to, this is not correct, I will correct it, is equal to adjoint of B into adjoint of A. Adjoint of A transpose is adjoint of A whole transpose. Adjoint of a diagonal matrix is a diagonal matrix only. These properties you have to study. The next is some operations on matrices. If you do some things, the determinant will not change. See, suppose A is a matrix having A, B, C, D, E, F, G, H, I. In A matrix, this is row 1, this is row 2, this is row 3. This is column 1, this is column 2, this is column 3. Now I will perform some operations on this matrix or determinant, whatever you want, you can. If I interchange 2 rows or 2 columns, that means, how will I show? I will interchange row 1 to row 3. Then what I will have? Row 1 will become row 3. ABC will come here. Row 3 will become row 1. GHI will come up. TEF will be there. So this is how I can change row 1 to row 3. Suppose if I want to change column 2 and column 3. In matrix A, everything I am doing from matrix A only. Then what will happen? Column 2, BEH will become column 3. And column 3, CFI will become column 2. But column 1, ADG will remain same. This is how I can show and make these changes. Next, suppose if I add one row to another row by multiplying k. This is what I will do. This is how I will write. Now, how will I show? I will show it in this. A matrix only we will change. Suppose I will take row 2 and add row 3 by multiplying k to row 3. So what will happen is row 2 will change because to row 2 I am adding. Then what will happen? Row 1 will be same. Row 3 will be same. Row 2 will change. How row 2 will change? I will take D. To D I will add. In row 3, G I will multiply with K and similarly, E will be same. To E I will add. H is multiplied to K and added. Similarly, F will be same. To that I will add. I will multiply with K and I will add. So this is the change I am doing here. And I am indicating like this also. Not only that, I can do in another way. I'll tell you another way. To column 3, I will add column 1, but I will subtract by multiplying column 1 with K. What change will happen? It will affect column 3. Column 3 will change. So when I write the matrix, I will write ADG column 1 same, BEH column 2 same. Column 3 will change. How will it change? In column 3, CFI will change by subtracting K times K into what? Elements of column 1. K into A, K into D, K into G. This is how I'm changing and I'm indicating the change. I'm telling you what change I made here, what change I made here, what change I made here, what change I made here. These all I'm telling. These all are shortcut methods to solve the determinants. I'm telling you the shortcut method. Okay. So after making these changes, whatever matrix I will get, that matrix I can name it as P. I can name this matrix as A. First matrix is A. The remaining changed matrix, I can name it as P. Here I can name it as B. This one changed one is B. This one changed, or you can name any other thing also. So here what they said is, two matrices A and B are said to be equivalent. So here A and B are equivalent. This A and this B are equivalent. This A and this B are equivalent. This A is equivalent to this base. This A is equivalent to this P. I will say A is equivalent to P. A is equivalent to B. Like this I will write. If I do all these elementary operations, this one, this one, this one, then A and B are called equivalent matrices. The next is inverse of matrix. What do you mean by inverse of matrix? Suppose B is inverse of matrix A. Then if you multiply A and B, or you multiply B and A, both will be equal to identity matrix. That means 1 0 0 0 1 0 0 0 1. If you multiply A and B and A, if you get this matrix, then B is inverse of A and A is inverse. B is inverse of A. A is inverse of, either way you get. Now, how to find these inverse matrices? If you want to find A inverse, you have to take adjoint of A. Just now I told you how to make adjoint of A. And then divide by determinant of A. You can easily get A inverse. But remember, determinant of A should not be 0. Or A should be non-singular matrix. Then only you can find inverse. If A is non-singular matrix. There are some properties of inverse also. These are the properties of inverse. Not fitting, and make it smaller. Okay, now it came. These are the properties of inverse matrices. If AB equal to AC, then you can say B is equal to C. If BA equal to CA, then also you can say B is equal to C. AB whole inverse will be equal to B inverse A inverse. Similarly, ABC whole inverse will be equal to C inverse B inverse A inverse. A transpose inverse will be equal to A inverse transpose. K into A inverse will be 1 by K into A inverse. Suppose if A is a 2 by 2 matrix and determinant of A is not 0, the formula for A inverse is determinant 1 by determinant of A. 1 by AD minus BC into, this is adjoint of A. Writing adjoint of A is very easy. For a 2 by 2 matrix, you can write adjoint of A very easily. Bring D here, bring A here. D and A you exchange. Similarly, bring C here, bring B here, exchange, but sign also you change, minus minus, they become minus. So writing adjoint of 2 by 2 matrix is very easy. Then determinant of A inverse is determinant of A whole inverse. If A is symmetric matrix, then A inverse is also symmetric matrix. Only square matrix will have inverse, that too if it is non-singular. And every matrix will have a unique inverse, only one inverse. You cannot have many inverses for one matrix. Tomorrow in class, we will do some problems based on this. B and C are exchanged. Where B and C are exchanged? Yeah, here. B and C are exchanged, but they will get the negative sign also, minus minus after it. You're right. So tomorrow we will do some problems based on this. Meanwhile, learn all these points carefully and come so that tomorrow we can do easily. You can get the answers easy. See you tomorrow.
Thank you, ma'am.
You're welcome.